Okay, in this lesson we're going to look at the Cartesian plane. Now the Cartesian plane is on the right, but before we get into the details of the Cartesian plane, let's talk about a number line, a more basic concept. So a number line, as you draw in early grades, in primary school likely, is just a straight line. So it's normally a horizontal straight line, and then you would have 0 somewhere. In this one I've chosen to place it in the center because I want to reflect both the positive side and the negative side of the number line. So these points are equidistant from each other. So you have 0 here in the middle, 1 unit to the right, 2 units to the right, 3 units to the right. Similarly, to accommodate negative numbers, you move 1 unit to the left, 2 units to the left. Early in primary we are taught the number line, and we use it for seeing concepts such as addition and subtraction. I just didn't show how that works here. That I can do that in a separate video. But basically, let's say you had to add 5 and then subtract 4, then you would move 5 units to the right, 1, 2, 3, 4, 5. Then you would move 4 units backwards, 1, 2, 3, 4. So you'd get as an answer 1 when you're doing 5 minus 4. Now a number line, that is an application of the number line to help us visualize addition and subtraction, but we can do a whole lot more when we enter domain of the Cartesian plane. With the Cartesian plane you have 2 lines meeting, so they are pretty much number lines. One is placed vertically and the other horizontally, and they coincide at their mutual 0 points. So now this creates the Cartesian plane, and we normally name this axis here the horizontal axis, the x-axis, and we name the vertical axis the y-axis. Now the Cartesian plane in this sense is a 2-dimensional field. Really, it's a 2-dimensional plot. We are able to plot points that correspond to some value on the x-axis and another value on the y-axis. So you could have a point here exactly, and this point would correspond to a value 1 on the x-axis and a value 1 on the y-axis. Similarly, you could have a point up here corresponding to a value 1 on the x-axis and a value 2 on the y-axis. And this is the purpose of the Cartesian plane, that we are able to show points in 2 dimensions. I'll move to the next slide to show how this works, and so that we can see extensions of these lines. These small lines here actually extend through the whole plane. Let's move to the next slide and see how this works. So this is what I was talking about, the small gray lines. It's these orange lines extending on the y-axis and on the x-axis, and we see where they meet. Now when we have a point here, perhaps let's look at that point there. That is 1 on the x-axis and 2 on the y-axis. So we label that point with what we call a coordinate pair. It's a value of the x-axis first, and then we do a comma, then we put a value of the y-axis. So this is the one, this one and that one I've labeled in this particular diagram. You can see that we are on the x-axis at -3, and we are on the y-axis at -2. And this is where, if you were to extend a line from -2 on the y-axis, when you reach -3 on the x-axis, this point would lie, and this point would be at -3, the x value, and -2, the y value. So we are able to visualize points in the Cartesian plane in this fashion. I will not go into the details of the graphs here, but once you connect points that lie in the Cartesian plane, you start to get curves and straight lines. Without particularly going into deep detail about that in this particular video, but we will cover that as I explain functions more. So you do get the idea that the Cartesian plane enables us to draw graphs. So we can have multiple points. Once we join those points, we start to have different types of graphs, and here we're looking at a curve and a straight line.